This is Physics 2212, Lab 1, Charge Tape. Here's a brief overview. First, we're going to go into the introduction, then we'll get into the physics involved. Then we'll look at the observed motion during the lab experiment, and then look at the computational motion produced from some of these results. Then we'll get into the results of the overall experiment, and then look at some key takeaways. Introduction. Purpose. The purpose of this lab is to gain an understanding of the interactions between charged objects. In this case, that is the two pieces of tape, and we'll compare these observations with that of a simulated model, and then predict the tape's charge and predict its surplus or shortage of electrons. Results preview. Positive charge of the tapes. The positive charge of the tapes resulted in the repulsion of each other when brought in close proximity. Determined to be positive charge because it was attracted to a plastic pen with negative charge. The electric charge on a single tape is 5.9 E9 coulombs. The tape is deficient of 3.70 e to the 10 electrons. Physics involved. Some of the fundamental principles and equations involved in this lab was Newton's second law, gravitational force, and Coulomb's law. Observed motion. In this experiment, the system was tape B, which is the upper piece of tape, and the surroundings were tape A, which is the lower piece of tape, and the Earth. The initial conditions were that the mass of each piece of tape was 2e-4 kilograms, and the length of each piece of tape was 20 centimeters. Observations/calculations. Distance between the two tapes was 1.27 centimeters. The charge of each, and we determined from this that the charge of each tape was 5.93 e to the negative 9 coulombs, and the number of electrons lost or missing, however you'd like to say it, is 3.70 e to the 10 electrons. Computational motion. This is my glow script code that I wrote up using some of the principles from Lab 0. My code manipulates the electric force equation using Q squared over R squared times R hat times 1 over pi 4 or 4 pi epsilon naught. We all know that equation. And I just manipulated that to solve for Q instead of E. Results. So the results of my lab was that the calculated charge in the computational model is nearly equivalent to that of the calculations done for the observed model. Some possible sources of error were that we assumed there was zero air resistance on the tape, and even though it is nearly zero, this still could have had some effect on it. We treated both pieces of tape as point charges rather than the full piece of tape having infinitely many charges along the length of the tape. We assumed that both pieces of tape also had identical charges, which could definitely not be true. We don't know that to be certain, but it made the lab far easier. And then here's a picture of the outcome of my glow script code, where it printed the magnitude of the force of gravity, the calculated charge of the tapes, and the magnitude of the electric force. Key takeaways. What if the electrons had positive charge and the protons had negative charge? What would change about the observations you made with your tapes and other charged objects? The tapes would still be of the same charge and would still repel each other. The tape would also still be attracted to the plastic pencil, assuming its charge was also flipped. Why? Why is it important to handle the charged tapes as little as possible? What happens when the charged tapes come into contact with your hands or other objects? The charges on the tape are not permanent, therefore, every time it comes in contact with another object, it has the potential to gain back the electrons it has lost. Thank you.